being staying healthy during this time. Uh, so it's the afternoon, and I'm going to keep it short and try to leave room for questions if you have any questions. Okay. Before we begin, though, I just want to say this is for educational purposes only. So please speak with your healthcare provider before applying any of this information. And I appreciate annual SDA Church that churches are being involved in educating the public about their health. So I really want to thank Sister Anna, Pastor and the other church leaders who are involved, and just thank you for the opportunity to do this. So today we're going to talk about COVID-19, what we've been learning and what we can learn for future pandemics, because we have to look into the future, right? And see, how can I survive a future pandemic if one so arises. I want to begin here with an interesting quotation from Bill Gates. So it's very interesting, his thoughts on this crisis here. This is from Bill Gates' personal blog, and it's from April of this year. And it's very interesting to hear his thoughts. Okay, he says here, one of the questions I get asked the most these days is when the world will be able to go back to the way things were in December before the coronavirus. My answer is always the same. When we have an almost perfect drug to treat COVID-19, or when almost every person on the planet has been vaccinated against coronavirus. The former is unlikely to happen anytime soon. Most of the drug candidates right now are nowhere near that powerful. They could save a lot of lives, but they aren't strong enough to get us back to normal. In his conclusions, which leaves us with a vaccine. There's no alternative. In order to stop the pandemic, we need to make the vaccine available to almost every person on the planet. Okay, so it's very interesting. Bill Gates is saying here that in order for things to really go back to normal, we need to have a vaccine. Okay, and his two options are either a drug or a vaccine. And he's saying, a drug is probably not going to be powerful enough. Therefore, we need to get vaccine and vaccinate almost everyone on the planet. That's pretty much what he's saying. But it's very interesting to note, and I think it's important for the lay public to be aware of this fact. A SARS-CoV-2 vaccine, so this means a vaccine for coronavirus, to help with COVID-19, but in a future pandemic, if it's caused by a new virus, it will not be helpful. Okay, I hope that makes sense to everyone. A vaccine that's designed for a certain virus can only work for that virus, all right? However, in the future, if a new virus arises, okay, which it will in the future, we should expect that there will be new viruses that emerge, then vaccines will not be that useful, all right? So I think we have to look at the hard facts and ask ourselves, what then can we rely on, to help us in a future pandemic if one so arises. Now, I want to just make clear, I'm not against vaccines. When I was young, I got vaccinated and so forth. So I'm not against vaccines, nor am I against drugs. All right. But we have to ask ourselves, are these things what we can rely on for a future pandemic? I hope that makes sense. And we're gonna see that really it's actually the answer lies in something else. Okay. So let's take a look together. Okay. So first, in a future pandemic, can we rely on a vaccine? Well, we touched on this a little bit. Okay. But I want to how long it takes to actually develop a vaccine. So here, this is a study report released in 2020 of this year, April. So very recent. Okay, and they say this is estimated that it may take around 12 to 18 months before a vaccine becomes available. Vaccine development takes time. Okay, so it's going to take 12 to 18 months. So this is in April. So pretty much what they're saying is a coronavirus, COVID-19 vaccine will not be available until probably next year. Okay. Now you have to realize already we're several months into this pandemic, and we have several million that's already infected, over hundreds and thousands actually already dead. The world's greatest economies are at a standstill, and we've nearly brought some of the world's most sophisticated medical systems at breaking point, all right? And still no vaccine in sight. And that's because these things take time to develop, as you can see here, 12 to 18 months, okay? This is another report, April this year, scientific report, and this is what they say. Because no coronavirus vaccines are on the market, um, and no large-scale manufacturing capacity for these vaccines exists as yet, we will need to build these processes and capacities. Doing this for the first time can be tedious and time-consuming. Realistically, SARS-CoV-2 vaccines, so SARS-CoV-2 is the virus that causes coronavirus, COVID-19, will not be available for another 12 to 18 months, okay? So again, you can see here that these vaccines take time, okay? But by the time that these vaccines are developed, already millions are going to be infected, and hundreds of thousands perhaps dead, as we see in our situation today. And so we have to really ask ourselves, if we're going to bank on a vaccine for a future pandemic, really, I think that's kind of futile, and I hope that's clear. Now, it may help you all to understand how a vaccine is developed. And when you see the process in order to develop a vaccine, it's going to become very clear to us why they take so long to develop. Okay, so first, in order to get a vaccine, first they need to get a part of the virus or pathogen and isolate it. So it could be DNA, it could be RNA, or it could be any part of the virus. Okay, so they need to get that, and then they need to test it on animals first, which is a good thing, right? You want it to make sure that you don't want to start off with humans because it might harm us. So they test it on animals. They test, does it work, and what are the toxic levels. After they've satisfied themselves with the animals, and this is several months of testing, then they move on to humans, and they get a small group of healthy humans, and they ask themselves the question, is this safe? Okay, so they test, is this vaccine safe? After they've satisfied themselves, then they test, does the vaccine actually work? Okay, then once they've done all that, then they determine, then it's good to go, and then they develop the vaccine, they mass produce it, then they have to distribute it. Okay, so as you can see, in order to develop a vaccine, it takes a lot of steps. They're very careful with vaccines, and they want to make sure that these things are safe and effective, and which is a good thing. However, you can see though that it does take a lot of time. So right now, in the public, when you listen to the news and the government officials, there's a lot of talk about vaccines, which is good, I think. Let's not be mistaken. A vaccine for COVID-19 will help prevent future outbreaks of COVID-19. So that's a good thing. But what we're talking about here is, what if in the future a new virus emerges? It could be a novel H1N1 virus. It could be another novel coronavirus, or another novel pathogen. What are you going to do in that case? As you can see in our current situation, a vaccine is literally futile. All right. Barack Obama, when he was president, they had a 2009 H1N1 pandemic. I don't know if maybe some of you might remember, they had another pandemic during Obama's tenure as president. And at that time, there was an influenza vaccine. And this was a new virus. And so what they did was they had to just quickly make some simple adjustments to the vaccine. But even then, it took 6 months until a vaccine could actually be distributed. And it says here, it came too late to affect the second wave. So there was a first wave and then there was a second wave. And even though all they had to do is get an existing vaccine and modify it, even then it took 6 months to get the vaccine out to the public. And it was too late to affect the second wave of the pandemic. So even even in a case where we can just make modifications, even then it still takes a lot of time. Okay. This is one of the leading vaccine scientists in England, in Great Britain. And when the coronavirus, COVID-19 broke out, the government or the funding body, they gave her millions of dollars. We're talking about tons and tons of money to develop a vaccine quickly. Okay. And even then, she says here, in the best case scenario, they're going to get a vaccine out by autumn of 2020, so September and October. Okay, so even when we're pouring tons of money into a vaccine to rapidly develop a vaccine, even in that scenario, we're getting we're getting a vaccine literally too late to really make any difference, right? So now some people say, you know, this pandemic is an example why we need a vaccine. You know, I saw somebody post on social media on Facebook, and they say, you know, this pandemic shows you what happens when you don't have a vaccine. Okay, maybe you thought something similar as well. Maybe if we had a vaccine, you know, it would have prevented so much of this chaos and this damage. However, let's think about this. Can you have a vaccine to a virus you don't even know exists? You can't. I hope that makes sense. You cannot have a vaccine to a virus that you do not know even exists. The novel coronavirus we did not know even existed. It's a new virus. That's what novel means. Okay, so therefore you cannot have a vaccine for a virus you do not know exists. All right. And so again, in the future, if there is another new virus, you can see there's going to be no vaccine available. All right. So vaccines are good. Vaccines do help. They've done a lot of good in public health. However, when we're faced with a new virus, depending on a vaccine is really quite futile. And I hope that is clear to everyone. If you have questions, just put in the chat and we'll try to get to as many questions near the end as possible. Okay. Now, how about medications? So if not vaccines, then how about medications? Maybe we need to just create some more powerful medications. Okay. Um, you know, medications suffer the same limitations as vaccines. Essentially, they take a long time to develop. And even right now, we really don't have a drug that we can confidently say works against COVID-19. And again, we're months into this pandemic, millions infected, hundreds and thousands dead, and still no real drug that we can use. This is Anthony Fauci. Many of you have probably all seen Dr. Fauci. He's one of the lead doctors helping the Trump administration navigate this whole situation. And this was in April 29 this year. He said there was some positive signs of a drug called remdesivir that seems to show some positive signs. But again, this is in end of April, months into a pandemic, and now we're just seeing some positive signs. So again, in the future, if another virus emerges, a new virus, a new pathogen, new bacteria, then really, depending on drugs also, might be too late for many people. Okay, it's not to say that we shouldn't develop drugs, but you can see that drugs like vaccines take a long time to develop. But by that time already, millions will be infected and many will be killed. And so, really relying on a drug is really not the best solution either. All right, I hope that's clear to everyone. Okay. Now, how about ventilators? You know, when the pandemic broke out, you know, there was a lot of panic. You know, we need more ventilators. Let's stock up on ventilators. How come we weren't ready with more ventilators? Well, ventilators are good, but I'm going to show you some stats that show you that ventilators actually don't save as many lives as we would like. Okay, so let's take a look here. So the red part of the graph shows you the percentage of people that were on a ventilator that actually did not make it. They passed away. Okay, so you look here, a study from China, Ireland, and a small study from Seattle. Okay, as you can see, 81%, 66%, 47% of those who are on ventilators actually did not make it. Okay, this is really unfortunate because you would think that if you're using such high-tech technology, that surely it would save the life. But as you can see here, even those who are using this advanced technology, advanced treatment, they actually did not make it. All right, um, and it makes sense. Uh, by the time you need a ventilator, already your disease has progressed so much that it's already too late to bring you back. Okay. Now, as you can see, it does save lives. Okay, you can see from the graphs there are lives that are saved, and I think all of us would agree that every single life is precious. And if we could even save one, two lives, that is still worth it. But what we're talking about here is that that we wish that these can save more lives, but it actually doesn't. So to take a chance just on ventilators themselves, as you can see, it's really a little bit of wishful thinking. Okay. This is a study from New York, and as you can see, the percentages aren't that great either. Okay, so ventilators do save lives, but the rates are not high. Okay, and I hope that that makes sense to everyone. Okay, I hope that you can see that. Okay, so should we stack up on ventilators? Yeah, sure, of course. We don't want to have to go through panic again like we did this time around. But as individuals, when we think about lessons from this pandemic, if you're going to rely on ventilators and hopefully that will like save you when you get sick and so forth, um, yeah, the science actually does not support that level of confidence. Okay, so if it's not vaccines, if it's not drugs and ventilators, then really what can we rely on? Okay, well, I want to ask you guys a question and to think about to get your thoughts going here. I want to ask you a question. Can our immune system fight off new pathogens? Okay, so can our own immune system fight off new viruses, new bacteria, new fungi, and so forth? Okay, this is a question that's actually not really being asked if you listen to the news and so forth. They're actually not asking about our own immune systems. Okay, but I think this is a question that we have to ask ourselves. Okay, can our own immune system, if it's functioning properly, can it actually fight off new viruses? Okay, and I think the answer is yes. Okay, let's take a look. I just looked a few hours ago on the statistics. Globally, we have I think 4 or 5 million people infected right now with coronavirus, the SARS-CoV-2 virus, COVID-19. Okay, and look at the deaths. Globally, there's 300,000 deaths. Okay, that's about 6% of all cases. Okay, so 6% of all those who've been infected with COVID-19 died, passed away. All right. It's very interesting though. 2 million have recovered. Okay, so 300,000 dead, 2 million recovered. Now let's look at Canada. In Canada, okay, I hope you can see the graphs. In Canada, there's about I think 84,000 cases. Okay, approximately 6,000 deaths. But it's very interesting. Out of 84,000 approximately, almost pretty much half have actually recovered. So they got the virus and they actually recovered. Okay, so to make it easy to understand, if you get 100 people, okay, 7 of them will have passed away from the virus. 51% would have actually recovered, fully recovered. They're doing okay, and the rest are still actively fighting off the virus. Okay, so it's very interesting. This is actually something that you don't actually hear about too much in the news. If you follow the news and so forth, it makes it seem like it's pandemonium. Everyone is gonna die if you get it. Like you're doomed, right? But that's actually not the case. Um, don't get me wrong. COVID-19 is a deadly virus. So let's not minimize that. But we have to look at get at least a somewhat of a realistic picture of what's actually happening. So you got 7 deaths. If you get 100 people with COVID-19, 7 would have died. 51 of them, so more than half, actually would have recovered, and the others are actively still fighting off the virus. So really, the question we have to ask ourselves is: the 7 people that would have died, that died, why did their immune systems fail? And the 51 that lived, why did their immune systems succeed? Okay, I think that is really the question we should be asking. Okay, so how come in a small group of people, their immune systems failed to fight off this virus? And in a majority of people, how come their immune systems actually succeeded? Okay, so let's take a look. Okay, you don't need to guess. There's tons of published papers coming out in the scientific literature about COVID-19. If you read them, you start to get a picture, and I want to present that to you. Okay, I want to teach you something new today, and if there's one thing that you all get away, it's this word here, phrase, cytokine storm. Okay, cytokine storm. Okay, just remember that. Okay, so what is cytokine storm? All right. The red thing here you see is the virus. Okay, it's a virus. It could be SARS-CoV-2. It could be any other virus. Okay, and the green thing here is your immune cell. Okay, when your immune cell detects a virus, it's going to release signaling proteins called cytokines. Okay, these blue circles, they represent cytokines. These are proteins. These are messengers. And what cytokines do, they signal to other immune cells in your body to get going. All right, so it's like a message. Hey guys, we have a virus. We have an enemy. Let's get going. Let's start fighting off this virus. Okay. Now, what's happening in COVID-19 is something called cytokine storm. Okay, cytokine storm. And so cytokine storm is basically your immune cells are pumping out tons and tons of cytokines, activating tons and tons of immune cells. All right. Now, some of you might be thinking, isn't that a good thing? Right? Like, why do we would want cytokine storm, right? We want more soldiers in the fight, more immune cells to fight off this virus. But did you know that actually cytokines, too much cytokines are actually detrimental? In fact, in many cases, what's actually killing people from COVID-19 is actually not so much the virus, but it's actually your own immune system. Okay, and you might be very surprised to hear this, okay? But that's actually the case. It's actually cytokine storm that's actually killing people. Okay, of course it was started by the virus, but it's actually this cytokine storm. So why is this bad? Okay, so let's unpack this. To help you understand, I want you to imagine 2 scenarios, okay? It's the difference between a normal immune response and cytokine storm is illustrated by police and like the military, okay? So if you have like robbers or criminals, police get involved and they get rid of the criminals, right? Usually there's not too much damage, right? Maybe there's a police chase, maybe some shots are fired, but not too much, right? There's not too much damage. Usually it gets resolved. But war is very different, right? You'd all agree. War is very different. Okay, so if police get involved, you might have maybe some cars that get damaged, some walls get some bullets there, and maybe unfortunately, maybe a few lives might be lost as well. But usually the damage isn't too much. Okay, however, in war, there's going to be a lot of collateral damage, right? Buildings are going to be destroyed. Thousands, perhaps even millions of lives are going to be killed, right? This war is like what's happening in cytokine storm. If your immune system is overactivated and you're in a state of pro-inflammation, lots of inflammation, it's going to cause collateral damage to the rest of the body or wherever the fight is happening. There's going to be collateral damage. And in coronavirus, the SARS-CoV-2, what's happening is your immune system, in its attempt to fight off this virus, it is causing massive amounts of cytokines to be released, massive amounts of your immune system to be activated, causing mass collateral damage in your lungs, and in other parts of your body. All right. And this is really the problem. All right. So you can see here, this is your lung. And so when a virus is activated, your immune system gets also activated. And so it releases tons of cytokines, tons of immune cells. You start to produce mucus, and your even healthy cells start to get destroyed, which makes it very difficult to breathe and so forth. Okay, I hope that makes sense. Okay, so it was caused by the virus, but an unregulated immune system, immune dysregulation, is going to cause an abnormal response and therefore advanced stages of this disease. Okay, I hope that makes sense. Okay, so to kind of close off here, so then in the 7 people, so remember we said if we have 100 people that are affected by COVID-19, 7 of them are gonna die, right? At least based on the statistics we have now. Okay, so then what conditions did these people have to elicit such an abnormal response in the immune system to the point where we could not get them back? Okay, and if you look at the studies, right, it's actually chronic diseases. All right, not in every case, but in many cases, these individuals who have died from COVID-19, they had heart disease, obesity, type 2 diabetes, and hypertension, and other ones as well, but these are actually the main ones. Okay, heart disease, okay, obesity, type 2 diabetes, hypertension. When people have these chronic diseases, they have a greater likelihood, a greater risk of actually dying from or getting severe form of COVID-19. Okay. Now, some of you might be asking, how could that be? What is the link between diabetes and obesity and COVID-19? Okay, so let's take a look here. When you have excess fat, okay, already your body is in a state of inflammation, chronic inflammation. Okay, so basically it's like your body's in a state of constant like battle. All right, and when you add another virus to that already pro-inflammatory mix, it's a perfect storm. It's a cytokine storm waiting to happen. All right, and so when people carry excess fat, this already their immune system is already in a heightened state, immune dysregulation. Okay, and this is very important to realize. A lot of people, when they think about carrying excess fat, they think it's just kind of like aesthetics. You're carrying, it might not look good or something like that. But from a health standpoint, it's actually the immune system is actually damaged when people carry excess fat. And that's very important to realize. Okay, you're in a chronic state of inflammation. And when you add another virus, boom, it's a perfect storm. All right. And when you have diabetes, people that have diabetes, heart disease, hypertension, often they are carrying excess fat. All right. Uh, okay, so let's take a look here. So the red bars represents those people who have a red represents the people who died from or have a severe form of COVID-19. Okay, so if you look at thin people who got the disease, 41.9% needed a ventilator. But if you look at the severely obese people, 81% of them had to eventually be placed on a ventilator. All right. This is a study from Italy. Again, 89% of the people who were admitted to ICU and had advanced stages of COVID-19 and who died, okay, or died, 89% of them were either obese or overweight. Okay, the statistics do not lie. In France, if this is a study from France, if someone had severe obesity, they had an astronomical 600% increased risk of being placed on a ventilator. Okay, 600% increased risk if they had severe obesity. Even if they were, even if they had kind of mild obesity, it was still over 200% increased risk of being placed on a ventilator. Okay, And these other diseases, if you look here, hypertension, 100% increased risk. Diabetes, over 200% increased risk of severe or mortal, or so from dying from COVID-19. Okay, cardiovascular disease, 400%. All right, and of course, old age is the biggest risk factor. Okay, most of the people who are passing away from COVID-19 or who have severe forms of COVID-19 are advanced age. All right, so so if people have chronic diseases, all right, their immune system is dysregulated, and therefore they are not able to cope with COVID-19, and the science is bearing that out. All right. Now, the good news is that these diseases, heart disease, obesity, type 2 diabetes, and hypertension, are preventable, and even in many cases, they're actually reversible. All right. And in the vast majority of cases, these diseases are lifestyle related. Okay, this is not good news, folks. Okay, these diseases are lifestyle related,
Yeah,
which means that we can actually do something about it. Okay, we can actually do something to help us perhaps um, face the next one with at least a certain degree of confidence. Okay, not perfect. Obviously, there's no guarantees. Okay, but at least with a reasonable level of confidence, if we live a healthy life, avoid these chronic diseases, then perhaps we could face these a future pandemic with somewhat greater confidence. So, how do we avoid these diseases? Very simple lifestyle practices, okay? Or at least principles, simple principles. First is eating healthy, a mainly plant-based diet, okay? And I'm so glad that the Seventh-day Adventist Church is holding this, because Seventh-day Adventists have long been proponents of healthy plant-based nutrition, all right? Eating plants, less animal products, less processed food, and eating more plants. Okay, eating plants is the healthiest diet really to be eating. Okay, and if you're here and you're a guest to the Seventh-day Adventist Church, you're not a Seventh-day Adventist, I want to encourage you to connect with the Seventh-day Adventist Church. There's going to be a lot of people there who are plant-based, and they can teach you perhaps how to kind of go through some of that. I know that Emmanuel Church, which is the host of this program, I know that they have several individuals there who can really help you with that. So, plant-based nutrition, I want to encourage everyone to consider the benefits of whole foods, plant-based eating. Okay, let me just skip this here. These are just scientific studies that show you the benefits of plant-based nutrition. Here, this is an individual. This is a heart. This is a heart vessel. You see, A here is somebody who had a clogged artery. All right, they're eating the standard American, standard Canadian diet. Lots of meat, lots of processed food, and so forth. You could see the heart here, lots of narrowing. Very scary, right? Heart disease. Okay. But you see, B here is, I think, over a little over a year on a fully plant-based diet. You can see here, literally that same vessel has opened up again. Okay, so you can see this is reversal of heart disease. All right. So scientific evidence suggests that even those who have a clogged artery, when they switch to eating whole foods plant-based, that you could actually start seeing those arteries starting to open up again. All right. And this is really phenomenal. All right, and this is seen with diabetes. Good scientific research to show that you could actually prevent, and not even just prevent, but even potentially reverse type 2 diabetes on a whole plant-based diet. Okay, and physical activity as well. I know lots of the guidelines, they say, stay home, don't go outside, and so forth like that, or at least limit going outside. But really, if there was a time that we need to be active, it is really now. Physical activity is massively important for your health. We talked a lot today about the immune system. The physical activity uh, helps uh, increase, or at least regulate, almost all aspects of your immune system. Almost every single immune cell in your body increases with exercise. All right. So this is really really important. And I want to encourage everyone here to get physical activity. Myself, during the pandemic. We had to see patients through virtual. So the number of patients in the clinic has gone down. So it's given me a little bit more time, and every day I've been going out, exercising, getting my runs, and so forth. And I want to encourage everyone else to do that as well. Use this opportunity to get outside and to exercise. Of course, practice physical distancing and so forth, but still, you can still go for runs, walks, and so forth. This is very important. Okay, this here, you can see different immune cells, natural killer cells, T cells, and B cells. You've probably heard of these cells. These are immune cells. They help fight pathogens and repair damage and so forth. As you can see with exercise, these immune cells go up. Okay, now you can see they actually go down afterwards. So you can see the graph goes down. So you might be saying, well, that's not good. How come they're going down? We want them to stay up, right? But it's very interesting. Scientific studies now show that with exercise, your immune cells, the numbers go up, but then they go down. And the reason is because they're getting out of your blood and they're going into your lungs and into your gut. All right, it's very interesting, your peripheral tissues. Now, what's interesting about that? Well, if you look at where most infections occur, it's through your lungs and through your gut, right? Your digestive system and through your lungs. It's very interesting. God designed the human body so that when we do something healthy like exercising, you increase the amount of soldiers, and then those soldiers gets redistributed into areas where there's a lot of infection. Okay, so isn't that amazing? The way that we're designed to benefit when we do these healthy behaviors. Okay. Now, some of you, if you're sharp students, you're thinking, but George, I thought you told us that too much activation of the immune system is not good. And I'm seeing here this graph, and with exercise, your immune cells are going up. Isn't that bad, right? But there's a catch, okay? Not only does your fighter cells increase, but also your regulatory cells. So in your immune system, you have these cells that actually regulate the immune system. So you get more soldiers, but you also get more regulators as well. And so actually with exercise, your immune system is actually more regulated. So this is amazing. You don't just get soldiers going Rambo, shooting and destroying everything. You got a more coordinated immune response. And that is really beneficial. So really with exercise, your immune system is really, you're doing so much good for your body by exercising. I want to encourage everyone to do that. All right. So Seventh-day Adventists, we have this acronym that is kind of popular. It's called New Start. All right. And each letter stands for a different aspect of health. All right. So N stands for nutrition, healthy plant-based nutrition, not processed food, but healthy whole foods. Exercise, water. So not coffee, tea, like caffeinated tea, not pop, juice and stuff like that, but just just plain old water, right? Sunlight. Sunlight is very beneficial. Okay, in fact, vitamin D is an immunomodulator. All right. Temperance. So temperance is not a word that we often use these days, but really it means self-control. All right. It's very unfortunate that we're getting reports that addictions are not those who are addicted to stuff, they're not doing well because they can't get access to services and things like that. Alcohol use, people are just staying at home, and what are you going to do, right? And it's unfortunate that they've labeled that they allowed I believe they're allowing beer stores and stuff to open, I believe, which is really rather uh, curious in my view. But temperance is means self control, and we want to get rid of things that are bad, unhealthy, and eat in moderation the stuff that's good for us. Okay, so alcohol, recreational drugs, and things like that. This stuff we want to get rid of in our lives. And even among the good stuff, we want to eat in moderation. All right, so self control. Air, okay, healthy, clean air. Okay, rest, so good amounts of sleep. Okay, and T stands for trust in God. Perhaps the most important aspect is trusting in God and a higher power during these difficult times. All right. So here, these are God's natural remedies. All right, food, exercise, water, rest, sunlight, and prayer, trusting in a higher power to help us. These are really the true remedies. All right. Now, it's not to say again that vaccines and drugs aren't important. They are. Okay, so if you're medicated and so forth, then yeah, please, stay on these things, obey, listen to your doctor's orders and so forth. But what can we do to prepare for the next one? And really, what I'm saying to you here is that chronic diseases is a major risk factor for um, advanced stages of infect of things like COVID-19 and potentially even dying from these diseases, these infections. And so if a new one hits, we want to make sure that our immune system is in top-notch shape. And really the way to do that is through living a healthy life. Okay, so closing off here, the most potent defense against pathogens is not outside of you, it is inside of you. Okay, and that's not being emphasized enough. Okay, in the vast majority of cases, nothing is more reliable than your own immune system. Your immune system can fight new viruses. All right, it is designed to fight new viruses. All right, but the question is it functioning properly enough in order to do that? That's the real question. Okay, and nothing replaces actually living a healthy lifestyle. Okay, a healthy lifestyle. In closing here, I just want to leave you with a thought. This is very interesting. This is from a paper released this year, 2020, about COVID-19. And the authors reflect on past pandemics. And look what they have to say. It's very, very interesting. Quoting now, since the Spanish influenza pandemic of 1918, it is known that malnutrition, both under and overnutrition, is linked to a worse prognosis. The 1957-1960 Asian and the 1968 Hong Kong influenzas confirmed that obesity and diabetes lead to a higher mortality, as well as more prolonged duration of illness. During the 2009 influenza A virus H1N1 pandemic, obesity was also linked to increased risk of severe disease and a risk factor for hospitalization and death. Okay, so what are they saying here? They're saying in 1918 pandemic, it was obesity had a link there. 1957, 1960 Asian pandemic, again, obesity and diabetes. 1968 Hong Kong, again, obesity and diabetes was linked. 2009 H1N1, again, obesity was a link. Okay, so really, my question to each one of us is, when are we going to learn our lesson? Okay, how many more pandemics do we need until we learn as a society that having chronic diseases increases our risk of dying from and getting severe forms of these infectious diseases? I think it's about time that we had learned our lesson and that COVID-19, surely from this pandemic we're going through, that we learned that really living healthy is really the way to go. This is the British Columbia's top doctor, Dr. Bonnie Henry. She said, "We've never had a pandemic in recorded history that has not had a second wave." So, everyone is worried about a second wave of COVID-19. Well, she's saying, likely it's going to come. Okay. And so we have to ask ourselves, what can we do? And really, I hope that what I presented to you today really gives you some food for thought. All right. So, in closing, whenever you ask yourself, what can I do for COVID-19 and also for future pandemics, I want you to remember this picture. If 100 people got COVID-19, 7 of them would have died, 51 of them actually would have lived. They would have recovered. And the question is, how come these 51% survived? All right. And how come the 7 passed away? Okay. And what the studies are showing right now is that not in every case, but in many cases, the 7 had some type of chronic disease, obesity, type 2 diabetes, heart disease, hypertension, something like that. Okay. And the we're relatively healthy. Not in every case, okay, but generally speaking, this is the pattern that we're seeing. Okay, so I hope that leaves you with some food for thought, okay, as you think about the future, right, of future pandemics. And if you're ever worried and wondering what you can do, just remember this picture. The majority of people who actually got COVID-19, the SARS-CoV-2 virus, actually survived. And the question is, why? And the answer is their immune system fought it off successfully. That is the thing. Okay, the immune system fought it off successfully. Okay, in some cases, they need the help of a ventilator. In some cases, they use some drugs and so forth. But in the majority of cases, they're actually told to go home, and they actually recovered at home. This means their immune system fought it off successfully, and I think that gives all of us some food for thought to think about. All right. With that, I think that closes off my portion, and so I don't know, Edna, how if you want to do questions or if you want to just close off here. But that is my what I want to share today. So, Sister Edna.
Hi, a question now, Dr. Cho. So anybody can unmute your phone and ask a question. I have